Before I talk about the subtraction property of equality, let's make sure we understand that when we see the equal sign, that means that both sides of that equal sign are going to represent the same value or the same amount. So for instance, this left-hand side is going to have the same value as the right-hand side. We can write this mathematically. Instead of a box with a question mark, I can use a variable. Let's say I use n. n plus 2 equals 5. So n plus 2 has to have the same value as 5. Now the subtraction property of equality comes into play when we use subtraction to isolate the variable. That means we're going to have n all by itself on one side of the equal sign, and everything else will be on the other side. So I'm going to do that by subtracting 2. Now when I subtract 2 on one side, I need to also subtract 2 on the other side of the equal sign. Now I have n equals 3. Notice that 2 minus 2 will give me 0. N plus 0 is the same thing as n. Now I've calculated what n represents. Before I move on, I want to check to make sure this is the correct solution. I do that by plugging in 3 for n, or evaluating. So 3 plus 2, does that equal 5? Yes, 3 plus 2 is 5, and 5 equals 5. Let's go ahead and do another problem without the models. Let's say we have 35 equals n plus 20. It doesn't matter if the variable is on the left side or the right side of the equation. Our goal is to isolate the n so that we can find out the value of what that n represents. Because I'm adding 20, I'm going to use the subtraction property and subtract 20 to both sides. If I just subtracted 20 to the right side, I will have changed the equation, and n would not equal what it would equal in this original equation. That's why we want to do the same operation on both sides. These are going to cancel, and so I'm left with n equals 15. Now let's check. Is 35 equal to 15 plus 20? Well, 15 plus 20 is 35. And you can see that 35 is equal to 35. So my solution is indeed 15.